Previously, we've looked at arrays. Now we want to look at how do we use arrays inside of functions. Because they're a collection of individual data elements, they have some special rules on how we're going to use them. Now, in some cases, they're going to seem very straightforward. In other cases, these are going to be a little bit weird. So let's first look at our quiz scores that we have here. We have a series of quiz scores. We've defined a variable that lists them out. I have some initial values, and I'm going to go ahead and finish filling this out because I have 5 listed, but I have 8 as a possibility. So here we have all 8 of our quiz scores. We're defining the size as well as declaring their initial values. That's very important for us, as we're going to see in just a minute. Now, when we create a function that's going to take an array, one of the things we often need to do is pass in the size of our array. The reason is very simple. Because arrays do not have a way for us to know how many elements are in them, we need to tell C++. So I'm going to create a function prototype real quick. We're going to return a double because we're going to get the average quiz score. We're going to specify that it's going to be an array. We don't need to specify how many at this time. And then we need to specify a size. Now that I've got my prototype, now finding an average out of my array is pretty simple. I need a running total and a for loop. I'm going to specify that I'm going to look for whatever my array size is and stop there. This is how I'm going to know how many elements I'm going to go process. I'm then going to take my running total and add each element to my running total. Finally, when I return, I'm going to take my running total and divide it by my array size. So this becomes pretty easy. And what's nice, now you might ask, why did I just take that constant value and use that in my average score? Well, I want to be able to pass multiple arrays to my average score. And I might have a different number of homework assignments versus quizzes, or I might have a different number of in-class assignments and things like that. So let's show you how we're going to use this real quick. Here I've defined a variable, quiz average. It's a double. I'm going to say it's going to be equal to average score. I'm going to pass in my scores value. So here's my quiz scores. I don't have to specify that it's an array. I just pass in the variable name. And then I will go ahead and use my constant value. This way I could use the same function multiple times. When I run and build this, it's going to calculate all that information for me and give me my answer. So this is pretty easy. However, there is a couple of interesting things that can happen. I'm going to show you what those are real quick. So this is a real easy thing to do. However, there are a couple of interesting circumstances we do need to be aware of. By default, when we pass a single element into a function, a copy of that variable is made. And that's great. The problem is, when we pass an array, we always pass by reference. We never pass by value. That's because an array here is small, 8 elements. However, I could have an array of 50 elements, or 500 elements, or 5,000 elements. And copying that much data actually becomes a real problem. It's relatively slow, and because of the way the memory is stored, I might not have a place in memory to place it. Therefore, when C++ is passing an array into a function, it always passes by reference, which means I can go in and change that value anytime I want it. Let's take an example of something like that, just so we can kind of see what it's going to do. Here I have a function called setScores, and I'm going to set my scores, obviously. I'm going to return nothing. Write this function real quick. We're going to start off pretty simple with an array, same like we did before. The difference is, here we're going to set the value of our scores. Here we're going to set the value of our scores, and we're using a random number to help us. So here we've calculated a way. We're just going to make sure we get at least a 50 on every score, and we're going to process it up high. I've added an L to my 50. This just makes sure that I'm using a 8-bit integer instead of a 4-bit integer. Gets rid of a warning that we might have. After I get my initial average score, I'm going to call setScores real quick. And then we'll get the average again. This way we can see what's going to change. Okay, so you notice right away there's a huge difference in my average score and how it's dropped. This is because we assign a bunch of random values to our quiz scores instead of those values that we initially set on our own. This is just showing you real quick how we can change those initial values. I could also use a for loop in order to go through each of my local elements. Now if I run this again, you can see how much of a change we actually had. Quite a large change in all honesty. So if we want to look at how do we make sure we don't accidentally affect and change a quiz score or any other array value, there's an easy solution to that. What we're going to do is come down here, and where we have our average score, I'm just going to add the keyword const in front of it. Now, we're not accidentally making any changes here in our average score, but it would make sure, or it would ensure, if you would, that we didn't. So by adding that const keyword in front of our array, we make sure that the array does not change inside of our function. Let's do this inside of setScores just so we can see the error that gets generated. You specify const double, and as soon as I do that, you'll notice that Visual Studio comes in and specifies that the expression must be a modifiable value. That is, it sees the const and knows that we can't modify it. So this would generate an error for us. And that's how we can make sure we don't have that issue if we're afraid we might make a change inside of a function to a value that we don't need to